Good morning to everyone. I am Dr. Sumi MS. The topic of my today's presentation is High Energy Ball Milling from Unit 2 Synthesis of Nanomaterials in Nanotechnology. On completion, the students will be able to explain about the high energy ball milling method along with its working principle and also understand the mechanism of particle size reduction along with its applications, advantages and limitations. Ball milling. Ball milling is generally a top-down mechanical process that is employed to reduce the particle size of materials. It uses balls in the form of steel, ceramic or tungsten carbide in a rotating or vibrating chamber to grind materials. They are applied in metallurgy, chemistry as well as in nanotechnology. High energy ball milling. A ball milling technique where the kinetic energy of the balls are found to be high enough to induce mechanochemical reactions and also severe plastic deformation is the high energy ball milling method. The working principle: chamber contains powders and balls and it involves in rotation or vibration causing the ball to get into powder collisions, and this results in fracturing of the particles, and it is subjected to cold welding and rewelding, and repeated deformation results in finally nanoparticles. Key parameters. Key parameters to be considered are the milling time, ball to powder weight ratio, the speed of milling, atmosphere in the form of inert gas or vacuum, and the type and size of the milling balls. Mechanism of particle size reduction. This particle size reduction includes plastic deformation, cold welding, fracture as well as hardening of the material, and repeatedly the above process leads to nano-sized grains. Applications in nanotechnology. They are employed in the synthesis of nanocrystalline powders, nanocomposites, that is metal matrix or polymer based nanocomposites, then alloying and amorphization in magnetic material alloys, and catalyst and ceramics. Advantages. This method is simple, scalable and cost effective, and there is no need for complex chemical processes, and this produces uniform and fine nanostructured materials and can be used for ductile and brittle material manufacturing. The limitations include contamination results from the milling media or the container, and it requires high energy consumption, and the processing time is longer, and heat generation will also affect the material properties. Safety and precautions to be noted: use protective atmosphere to prevent oxidation, regular maintenance of the milling equipment is needed, and adequate cooling or intermittent milling to avoid overheating. And recent advancements: this method is employed in situ monitoring techniques, cryogenic ball milling being developed for temperature sensitive materials, and also reactive ball milling method for direct synthesis of compounds. These are the recent advancements in this ball milling field. Quiz questions on high energy ball milling. What do you mean by high energy ball milling? Explain its working principle. Explore the mechanism of particle size reduction along with its applications, advantages and limitations. Thank you.